Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to look at finding slant asymptotes of rational functions. So to find an asymptote, we are just simply going to divide. We're just going to take the top, the numerator, and divide it by the denominator. We did this in a previous video in order to find the horizontal asymptotes. We're going to do the same thing here, and this will help to show us what's happening on the end behavior of this rational function. So I'm just going to take my numerator and divide it by my denominator. So x times what gives me x squared? Well, that would be x. So x times x gives me x squared. I subtract, and I'm left with a 0 there. Bring down my 2x. X times what gives me 2x? It's plus 2. Multiply, you get 2x. Subtract, and that's 0. Bring down your negative 1. So there's a negative 1 over x, which is your remainder. Now, this part, the whole number, not the remainder part, this part is your slant asymptote. So there's going to be a slant asymptote where y equals x plus 2. Remember from graphing linear equations that this is your y-intercept, and then here is that's the y value of your y-intercept. So your y-intercept is at 0, 2, and then your slope is at 1, is 1. So in other words, there's going to be a slant asymptote if I go up to 2, 1, 2, and I go up 1 and over 1 from that value. So up 1 and over 1, and again using that slope, up 1 and over 1, there's going to be a slant asymptote in this function that looks something like this. And on the ends, my graph is going to do something where it's getting closer and closer to that asymptote without ever hitting it. So this talks to me about the end behavior there. There will be some slant asymptote that it's getting closer and closer to. Here's another example of that. We're just going to find the slant asymptote, and the way we do it is we simply divide. You take your top, your numerator. Now this numerator is missing a few terms in there. I'm going to help to fill those in because it doesn't have an x squared term, but I can make 0 times x squared is just 0, so we wouldn't normally write that. But to help us with our division, we need to fill in those missing terms. And then we divide that by our denominator, x squared plus 2x. Then we just ask ourselves, how many times does x squared go into 3x squared cubed? In other words, what would I multiply this by to get to that? Well, I would need to multiply by a 3 and an x. So 3x times x squared gives me 3x cubed. 3x times 2x gives me 6x squared. Now we subtract. So that becomes 0, and this leaves us with a negative 6x squared. Bring down your next term. Ask yourself again, x squared times what gives me a negative 6x squared? And that is a negative 6. Multiply, so you get negative 6x squared. Be sure to distribute, negative 12x. Subtract, so I have 12x. Bring down your next term. X squared, oh, it doesn't go in there. This is bigger than that. So that means this is my remainder. So I have a remainder of 12x plus 1 over that x squared plus 2x. So again, this part here tells me my slant asymptote. So I know there's going to be a slant asymptote at where y equals 3x minus 6. And again, to graph that, this is my y-intercept, 0, negative 6 would be my y-intercept. And then from that, I would use my slope of 3. Remember, that's That's 3 over 1. I go up 3 and over 1 from that point. And I know that that linear equation is my slant asymptote, where I would expect my rational function when I graph it to get closer and closer to that on the ends. Hope that helps you to find those slant asymptotes. Math made simple, it's Simpson Math. Thanks for watching.